Good afternoon, everyone, and a very warm welcome to this special session, which is a roundtable discussion with industry experts from NASSCOM. Over the course of the next 1 hour, we will delve into the topic Engineering a Sustainable Future, Designing for Circularity in India. At a time when the world is witnessing an accelerated transition towards cleaner and more sustainable mobility solutions, circularity begins with design itself. By leveraging digital engineering, including digital twins and now AI, companies in the automotive ecosystem can integrate the 4 Rs: reduce, redesign, reuse, and recycle from concept to the end of life of a vehicle. This data-driven approach aims to optimize resource efficiency, minimize waste, and extend product life cycles, thus promising to drive sustainable growth in the automotive sector, which in India is a promising one. I'm Mayank Dhingra, and it is my honor to invite on the virtual stage our esteemed guests for today's discussion. May I start by inviting Mr. Ashish Sharma, Head of India Technology Center, CNH, Mr. Sreenivasa Chakravarthi, VP IoT and Digital Engineering, TCS, Tata Consultancy Services, Mr. Thomas Mueller, CTO, Wipro Engineering Edge, and last but not the least, Mr. Guru Mallik-Arjuna, SVP Mobility Solutions, Bosch Global Software Technologies. Gentlemen, thank you very much for being here for this special roundtable on our theme, like I mentioned, Engineering a Sustainable Future, Designing for Circularity in India. I would just open this floor by asking a quick opening remark from each one of you. Given that the sustainability push is quite rampant right now across the world, how do you see design playing a role in determining circularity or recyclability of a product in the automotive industry?
For us, also coming from the automotive mobility sector, we are moving from typical value chain approach to a value loop approach. In the past, we always had source, make, and deliver, but it was very hard to come back to the how do you recycle the whole thing? How do you reuse the whole thing? I mean, that was something was missing in the entire value chain. But now with the value loop, whenever there is a product that is being manufactured, whether it's a component, whether it's a vehicle, whether it's a battery, whatever that we're talking about, it goes to vehicle maintenance, it goes to the component maintenance, and then it always goes back to either in terms of reusability or in terms of reusability or recyclability. And then we look into how do we get the best out of it. And now, on the source, we're looking for whether we can go for carbon neutral sourcing. And while we're making, we're looking for how do we reduce the waste that we're creating. And once we deliver, we're also looking for recycling. So that's my take that as an industry, I think we will move towards this, as I mentioned, value loop. And where both AI and design for environment will become the key differentiating factors for us to build not just about longevity of the product, but also about getting this circular economy while recyclability can be enabled. So that's my view on why it's so important for us.
Right.
So let me go next, Mayank. I strongly believe that one has to be sustainable by design, right?
Mm-hmm.
In like the value loop that Guru spoke about, which means that when you start a program, you have to design for sustainability. Sustainability is not an after effect to be managed. And therefore, sourcing while is very important, but also I would say if we go one step backwards, material science is probably going to play a very, very critical role in especially in decarbonizing the products themselves, especially since we are talking about mobility and cars, which do consume a fairly high level of metal. So decarbonization there will come through the advances in material science. And since you spoke about AI, actually, the lightweighting or alternate material definitions, which will still give you the same results on safety or resilience and so on, are going to be the future. That's where we are going to use a lot more about simulation and AI-based techniques to be able to get to customer delight features, but also address the issue of sustainability. So therefore, I would say sustainable by design has to become the motto in the days to come, and then it will translate automatically into the overall ecosystem becoming sustainable as the usage increases.
Right. That's a very good phrase there, sustainable by design being the motto. So Ashish, you have your thoughts on that? You would like to add to that?
Sure, Mayank. Yeah. So, being closely associated with the design, as part of my current role, generally we look at three areas as we develop these machines for off-highway applications. One is the reuse, and from a design perspective, you have concepts of modularity, for example, as you are developing the parts or subsystems. Just taking an example. Second is repair. See, it's important because we want to make sure. See, repair has a couple of aspects. One is the repairability. Second is the repairability or right to repair by the customer itself. See, this is important because if you look at, let me just take an example of a consumer product which most of us use on a day-to-day basis, a mobile phone or an Apple mobile phone, right? Now, you have to go only to an authorized station to get it repaired, right? Nobody else would be in a position to repair it. And that results in more of a wastage of electronics. If we look at the machines we are building today, more and more electronics is coming into iron. And that's making it more and more difficult for users to repair it themselves. Again, I'm speaking from the context of our business, where our customers are farmers who have been used to in the past to repair the machines during the seasons, but today they struggle. So that's the second aspect from a design perspective, how we are building the tools, which are simple, could be made available to the customers eventually for them to be able to repair. And third is what the panelists also talked about is the recyclability. We, in fact, as an organization, globally have a goal to get to 90% of recyclability by 2030. So all the materials we are using in our machines consciously, so it automatically comes into our design specifications and design criteria. That's how design is helping on this larger initiative.
Right. Coming to you, Thomas, you want to give your thoughts on this opening comment?
Yeah, let's. My fellow panelists touched on a number of key points here already. From our side, at Wipro level, we have a sustainability program at corporate level implemented that we execute jointly with a number of our clients in integrated initiatives. So we are implementing technologies, across domains that allow us to really provide sustainability visibility to the leadership of our customers, and from there to circle back into the products. In the mobile space and the mobility space today, especially in the passenger car segment, we see already that, for example, major parts of the interior today use recycled materials. Vegan leather has become a mainstream option in many passenger car makers all over the world today, which I believe is a great way to see this. But moreover, it's also a question of the economic scales. Battery technology and the recycling of the materials that are valuable in the EV battery chain is still poses a major challenge. While all car makers are working on sophisticated ways of doing this, the mass execution remains a challenge of recycling of EV batteries that will be used both in the passenger car segment, the on-highway, the off-highway segment to a degree. And I think there is a lot of work that needs to be done globally to come to compatible recycling procedures that allow car makers really to do this at the global scale. Today, this is isolated pilot projects in small geographies. The energy use of these recycling technologies is intense, so it's an enormous energy that is needed to make recycling feasible. So it's also, from an economical standpoint, not optimal. So this is areas that I believe the industry as such really needs to address. And at the moment, as we see the economic pressure mounting on the automotive space globally, I think it's something where I'm concerned about, that the industry will be able to sustain the necessary investments to make that full recycling, especially of the battery technology, a feasible approach. So we'll probably see this shift from this decade into next decade to be available at global scale.
Understood. And in fact, you raised a very valid point, Thomas. In fact, this was the next question that I was, planning to put to the panel out here. Guru, if I may come to you, what Thomas has just brought upon to the discussion here, with this global transition towards electric vehicles, do you think right now the big focus is on recyclability and circularity when it comes to the battery itself? Do you think that is the main agenda for the entire automotive industry right now?
No, I think if you look at what is driving as a pain point today in the industry is the cost elements first. Yeah. So if you really want to say what is prioritized today is really looking at how do we bring down the cost, how do you make it available for larger user base, how do you make it the battery fast charging. So first thing we are doing as an industry is to look at how a software could enable to extend the life of the battery. Now, how to do this? We could, of course, look at the battery dynamics and monitor it on a regular basis, and look at the charging cycles and provide the best optimal use of the battery. So that if some battery probably today termed as 7 years life, we could probably extend it to 10 years. So first thing we're looking at is how do we extend this battery on a longer life, which is the durability part. That is what I would say is a first most priority that is coming in the industry. Second, we are looking at, of course, how do you package the entire battery also, right? I mean, in electric cars, what is also changing is in the past, in a typical ICE, we used to have hundreds of components. Yeah. And when we move into the EV, we are getting into the X-in-1 concept. It's no more that I have like similar 100 components. Even whatever we have, we are trying to put them together. And also brings down amount of the hardware that you use, electronics that you use. And the third we are looking is the kind of chips that we are using. We are moving towards the silicon carbide, which are highly efficient chips that we are moving into. So whatever the electronics we're bringing in, we're also looking what is the most efficient chips, efficient semiconductors can be used, which also again brings the energy efficiency, because it's also about one is a battery, but also what it consumes, right? It's also about the well to wheel is still a big question mark. While we're not talking about wheel to wheel, that's also where there's a lot of focus going on. And then, of course, I will come to, of course, we have to look into recyclability. Maybe just that we still don't have so many cars that are probably throwing the batteries out into the ground. But then there is extension of it by using it for the different purpose. There's a repurposing happening to the batteries. So I would say technology will evolve. Even the battery technology will evolve, right? We go into solid state batteries. So there will be a lot more efficiency will come in. And at the same time, even battery, how do you recycle even more will also happen. So majority of the components, we are trying to do this. In some cases, even the motors, the kind of earth material we're using, the magnetic earth material we're using, we're also trying to see how to eliminate them using different technologies. Would be through software, through other ways of doing it. But we are also trying to minimize the dependency on those natural earth material, which also leads to other kinds of issues. So it's an overall, I would say, ecosystem that we are addressing, and we will address each one of them on a priority basis.
Right. Srinivas, you have anything to add to that?
Yeah, I think in continuation to what Guru mentioned, when we talk about the innovation in this ecosystem, there are interestingly already some young companies which are looking at the recycling phenomena and what are the ways in which we can actually create a mechanism by which the post first life battery could actually be repurposed for a second life, maybe industrial application, and then that gives you an extended life, and then you can then decide what you want to do next. However, one of the lessons that we probably need to take away from other industries, like Ashish was mentioning about consumer products, if you see the challenge is when we are manufacturing at scale and dispatching in a very harmonized logistics operation. But when you want to do a reverse logistic operation, it is not scaled. You and I as individuals will have to volunteer to push it back into the reverse logistics system. The cost attached to it is higher than the cost when you are doing the forward transaction. So how do you incentivize the recycling process? And today, if you see, we are still in the very early stage of the EV adoption, and probably not much of battery would have even come up for recycling. When this penetration of EV into the larger vehicle ecosystem touches 50%, 60%, or 90%, then the amount of battery floating in the ecosystem is going to be much higher. And that's when we have to be prepared to manage this entire operation. And therefore, I would say the industry also has to come together to look at pre-designing both the reverse logistics model, the second life model, and then the final disposal model, so that we don't end up doing what plastic did to the larger environment. So that's what we probably would need to be careful about.
Ashish, could you give us a sense of how you're looking at it from an off-highway segment perspective right now?
See, honestly, Mayank, when it comes to EV, our industry is not at the forefront compared to the on-highway automotive industry, and more so in the Indian market. See, globally, we have just introduced smaller construction products like small excavators. We are introducing backhoe loaders, which are electric. But again, they are not in mass production at this point in time. Okay. But then as an organization, sustainability from a product perspective, we are also extending it beyond electric. For example, I think we probably spoke earlier about it. We've been developing methane tractors. Now, that's a different way of looking at circularity in our business, because you generate methane through the bio waste. So we are investing in technology which is helping generate methane at the fields using the bio waste. And we have developed tractors which run on methane itself, right there itself, right? So, and then the byproduct of that is again something which is going back into the fields as a manure. So as an organization, we are looking at alternative fuels as a whole thing, where EV is one part of it. So we are selectively looking into it. I'm sure what the automotive industry will do will something, which is going to help set the framework, and we most likely will be adapting that framework when it comes to overall sustainability from a EV perspective.
Right. No, rightly so. I mean, the off-highway segment, typically it follows what the on-highway segment usually does. So you still have some time to sort of emulate what the main market is going to do. I just, Sreenivas, you mentioned briefly about, regulations as well. So just want to get a sense of, how do you see this evolve going forward? Do you think it is going to be a big, the evolution of circularity when you talk about EV batteries is also going to be dependent a lot on regulations, what the government pushes for? Or do you think it's going to be like usually it happens, it needs a strong collaborative approach between the government and the industry? So if you could give me a sense of that, and I want perspectives here from both you, Sreenivas, as well as Thomas as well.
Sure. See, regulation will have a limited role to play. So it's at the end of the day, it's a market force, and for the market to work efficiently, the players have to collaborate. Obviously, there is no doubt about it. The economic model actually has to work out. See, once the economic model is put in place, which means that the supply chain actually is viable, and it is possible to make it happen, and that will happen when the volumes are decent enough.
Correct.
Then the participants will automatically become voluntary contributors to the overall good. Regulation can only probably help by saying that, yes, you must form a consortium, you must do A, B, C. For example, the volume of batteries you ship out, once you reach a certain point of inflection, that's the volume of batteries you should recycle, right? Those kinds of expectations can be set.
Right.
But you can't regulate the flow. It has to be market driven to be, viable in the long run as
Okay.
such. Yeah.
Right. Right. And Thomas, coming to you, you also mentioned about, the need of investments to be able to make this happen. Now, do you see some role of incentivization from the government in this entire thing of circularity when you talk about EV batteries? I mean, do you think that is going to be a vital force when it comes to ensuring recyclability and like safe disposal of these batteries eventually, even after the second stage application?
Well, to be honest, if you asked me 2 years earlier, I would have given you a different answer. It's 2025, and the geopolitical agenda has, I would say, significantly shifted. EV incentives, especially in the retail space, have been widely scaled back or are looking to be scaled back in major economies.
Yeah.
So governments are hesitant to basically subsidize electrification as they did maybe 2 or 3 years back at the, let's say, earlier stages. So this is something that makes me think that the governmental support for recycling, the financial side, is most likely not going to happen. There is an economical side to this. If you look at, for example, we spoke about, Guru mentioned electric motors. The use of rare earth materials has significant advantages in terms of energy density in those type of motors that use these materials to a significant point. We've just seen, a few weeks back, the announcements in the passenger car segment of single motor engines that exceed 600 kWs on a single motor unit. And that is significant. You can only achieve this with rare earth materials. But then on the other hand side, the cost of those materials have significantly spiked over the last maybe 10 years, if you track this. And going forward, every country is looking where resources can be secured on its own soil, or where foreign contracts can be seen. We've seen headlines in the last months of circulating around those type of deals that are being made, and most car makers went out directly to secure their supply chain around materials that go either into batteries or motors themselves. There is a high incentive to extract those materials from, example, motors that are coming to the end of their useful life. But the process to do so is still under research, and there is an enormous potential to optimize those. If you look at the ways today to extract rare earth materials from a motor that is to be disposed, it's an extremely costly process that invalidates the financial return. So there's an incentive to work together across the research chains globally to identify ways where motors can be disposed, at the end of their useful life where they are. I mean, most global OEMs today operate in 50 plus countries, and their products, ship to potentially more countries than that.
Right.
And those products at the end of their useful life cannot be, repatriated to the source of origin economically. And so we have to find ways. And to me, the example to avoid is what we see in the shipping industry. Was the boom in shipping, the constructions, globally went significantly up. But at the end of a useful life of, large ships, we see an economical disaster that happens next to India shores, typically, which is something that really concerns me. And the environmental impact is significant. So to find better ways across this, and it has to do, of course, with technology players like us that can help our customers to design this from the beginning. And I want to go back also to another point Guru mentioned. A lot of the usefulness of a product throughout its life cycle depends on the fact that the product can be kept current. We call this evergreening. It's something that in the IT industry, has been a state-of-the-art technology to keep applications updated at all times. But the electronic stack in all these products, whether it's an on-highway product, an off-highway machine, these machines have 50, 100 million lines of code today. And in most of these products today, it is not standard that this code can be changed over the entire lifespan of a machine. And it's typically only a small segment, maybe the cockpit application that can be updated in modern products. But again, this remains isolated for other parts of the product. This is not state of the art. We need to come to a point quickly that we can manage 100% of the software code over the entire lifespan of a machine sustainably. And that means we need to have the technologies in place to do this in the long run. We need partners that can do this for those customers. Sustainably, we need to come to agreements on technologies being used, like coding techniques. If I look into our industry, in the embedded space, we're using programming languages that are nearly 40 years old, and those languages are not safe to use. It has been, flagged in many industries, but we're starting to mass migrate code for our customers from unsafe languages like C and C++ to safe languages that are, useful for the next decades of use. So this is an opportunity also that I see for us to help our customers, exit those technologies, which are very sticky to the domain. If we look into automotive, we have sticky technologies like Autocar, which have been around for, probably 2 decades. And those technologies are, attached to those type of programming languages. So we need to look into the whole sustainability and also the safety. The fact that products get deprecated because of cybersecurity is widely visible. We have major car makers who cannot continue profitable products because they are not cybersecurity certifiable anymore. Porsche has, some examples of that recently with the Macan. And that's something where we see an opportunity to really look at the technology side, the EE, electronic architecture of those products to really improve and become compatible to each other. That's another aspect. Today, this is all closed source. There's no use of really accessible open source other than Android operating system and maybe Linux in some areas. But most of the functions are closed source, so there is no easy handover to a third party to deal with those type of applications.
Yeah, I mean, just to add what Thomas said, I'd extend, if you look at those languages today, with C++, and now there's a new language called Rust. Now, if you go into Rust, it actually, if you adopt this, you can eliminate almost 98 to 19% of the memory linked errors.
Okay.
But it's not easy to adopt, of course, because we are holding back of the code, lines of code, 1,000 lines of code for many years, and you can't just go and replace. The switching cost itself is much higher than the benefit. But yeah, we have to be conscious to see how you build for the future. So one other thing we are looking at, whether software, hardware, we are looking for more of a building block approaches, so that we can simply pick up those different building blocks and construct a new application, a new component, rather than having a very constant, rigid structures built into it. So those are all part of the reusability, if you want to call it as. It also brings speed, and there is also a lot of cost to it. So I feel there is so much more we can do in the industry to become more competitive and also bring the sustainability into the focus.
And if I can just, with that comment of yours, Guru, if I can also switch to the technology part of it, what are the enabling technologies right now that you see are helping the industry to move closer in this direction of achieving circularity and sustainability with design? I mean, you're looking at integrating your supply chains, the entire ecosystem. So are we looking at, the digital twin has been around for so many years now, but now as we move in the era of AI, so how is technology sort of enabling or is acting as a key enabler towards this goal?
Yeah, I think technology will play a very, very key role in the entire value chain, whether it is logistics, material handling, in the plants, and the way you deliver to the customer, the experience to the customer. I think it comes in various, touch points of the entire value of the vehicle or a component. And to take some examples, if you look at AI can facilitate optimizing the material life cycles from design to end of life management. What we're doing with AI algorithms is that we are trying to predict what's the material degradation, how can we optimize the recycling process, how can we enhance remanufacturing strategies. So it also start promoting, sustainability. We are looking at, for example, blockchain. When you talk about batteries, question is always about resale of the vehicle. And one of the major hurdle there is will they believe what is the kind of battery usage has happened, whether that can be reused or not. So there are questions about how one would trust the other person, right, when the seller and the buyer. And there is this battery passports coming in, and they are talking about blockchain integrity to this, because blockchain, it can definitely manage the entire ledger for transparent and tracking the material and products. And the industry like automotive, especially in the EV industry, we expect the blockchain will have a major impact in terms of bringing this trust level higher. and reduce the risk of fraud or double counting, whether it is even in the carbon credit trading as well. There is a lot of greenwashing that happens, and we expect blockchain could solve these problems going forward. And then if you look at digital twins, the whole industry is talking about how do I manufacture a vehicle and deliver to customer within 2 years. I think now we talk about how speed the Chinese OEMs are able to deliver the vehicles. And we can't go with the classical way of validation where we waited for the vehicles to come and then we wait for the prototypes to happen and then we deliver sample A, sample B, sample, the typical development cycle that we followed. That took us normally 3 to 3.5 years. Now we are saying, can we go use the digital twins? How do we bring virtual replicas of physical assets? And can we do a lot around the simulation, virtual simulation, and enabling those real-time monitoring? So this could advance a lot of, the vehicle validation aspects earlier in the design phase and not to wait until we wait for the first prototype to happen.
Right.
Or even digital twins are coming when we are having huge machines. We can't wait everything to be manufactured and then wait for the test, but you can actually create a digital twin of it and then test the entire thing through simulations. And we can get into as close as the real-time application. So it's very much possible. So we feel, I definitely feel that these technologies will be very, very instrumental, not just only automotive. I mean, from the vehicle perspective, whether it's manufacturing, whether it's energy, I feel there is so much more we can achieve using AI, using digital twins or blockchain. Now, if you want to apply AI even in my software development, I feel there is, with GenAI coming in, there is even more benefits we foresee. For example, if you want to choose what is the best specification for my hardware design, what are the best components that's available? Today, you've got hundreds of specification sheets available from various manufacturers. But GenAI can actually manage this data and provide us what is best available for me to move forward with my design activities. It would have been a lot more manual in the past. And so GenAI can be applied from the hardware as well as for the software in the entire development cycle to start improving on terms of how fast we can do this and how much we can reuse it. So it's a huge benefits I feel that we can achieve out of technology.
Right. Srinivas, if I can get your perspective on this, like Guru just mentioned, with so many different tools available now. So in your case, are you collaborating with your OEMs and maybe tier one clients at the conceptualization stage itself right now to look at design-based circularity? From the conceptualization stage itself, or are companies still waiting for the longer run, till the first prototype is built and only after that you go and you do another analysis on it?
Yeah, I think first we have to appreciate that it is an evolving space. So it's not a fully mature space, but it is evolving at a very rapid pace. So if you look at the design to launch cycle, the entire focus of this new age technology is to cut the NPI cycle time, right? That's where the value will get created. And when we look at what is the art of possible today, and even since you spoke, right, all of us are on the NASSCOM council, we looked at where does AI get into the product and where does AI impact the process. So both of these are large fields of their own. And when you look at AI getting into the product, it will lead to differentiated customer experience and, of course, real-time performance assessment and enhancement of the product. So that's one part of it. But since we spoke about using, for example, digital twins for the process side of it, you can certainly today look at the traditional methodology and see what part of that is redundant, right? Because it is sequential, and you need to wait for a certain period of time before the results come in. But if you could run those test cases with a certain set of design principles in place and choose which is the options that you would like to go with, it certainly helps. Now, let me give again a parallel from a very different but complex industry. which is, for example, life science. When I say life science, you look at what we have learned of how vaccines are made much faster today, right? The variants are being launched. Different molecular combinations are tried out before and tested for efficacy, and you narrow down that entire cycle of up to clinical trials, and even that you can, today fast track. Is what this industry is attempting, especially the new age companies which are biotech driven, right? And there's a tech element to it.
Right.
If you take a leaf out of that industry, then that is certainly possible in the industrial world, the automotive world, the mechanical world, because you're dealing with far more discrete elements here, and the behavior of many of these discrete elements is known.
Right.
The behavior of chemical entities and molecular entities is not that well known. But the behavior of most of the industrial elements is pretty well known.
Right.
So the opportunity to create twins or any AI-based methods to be able to not just simulate, but even virtually create. And therefore, I often refer to it as digital product creation.
Okay.
Right? It precedes the physical product creation. And that's where you will start gaining the, the innovation cycle crashing. Because you will now be able to eliminate a lot of variables well in advance. Having said that, there is one more dimension which is going to make this even better, and that is the decoupling of the hardware and the software. So, up till now, it was all intertwined. But now, with the software-defined concepts coming in, it allows you to leverage all the principles that we have learned in the software product development industry into all these assets that we are talking of. And if you're going to use standardized platforms from the hardware side, you can do feature launch, you can do personalization using the software context. And that is where the further reduction in the time to market will come through. So, and because the software by definition itself will be data rich, and you can play around with it. So that allows you to do a lot more than what you're able to do today, right? So at least a good portion of what you are planning to launch can be simulated and can be tested virtually. Right. So I think that's what we have to look out for. So it's a parallel development. I think early in this session, Guru spoke about the evolution of the electronic side and more well-defined chip architectures coming in. I think that's where we have to look out, right? The software-driven capabilities are also progressing in parallel. Material science is progressing in parallel, and we are looking at vehicle design. So all of these, when the confluence of this happens, that's when we will see value. So it's not an isolated linear value chain that we are actually dealing with anymore.
Only additional point is virtualization. Today's credibility of the virtualization is a problem. Because you can use for your test softwares, you can use for your internal releases, but if you say I'm going to release it to the customer usage, there will be a lot of questions will be coming in. So it's not easy yet. We've not reached that kind of a maturity yet in it, but definitely it can advance quite a bit of validation much faster than waiting for the real physical prototypes.
And also one element that I wanted to touch upon, Guru, is, with these different materials, we're looking at all these sustainable materials as well, like we talked at the start of this conversation. How do you see the industry mitigating the cost challenges arising from the use of these sustainable materials?
Yeah, I mean, hope we all have the magic wand to resolve this. But yes, there is high cost for everything that is sustainable today. If you want to go towards lightweight, eco-friendly materials, it gets expensive because they're all typically recycled aluminum, biocomposites are more expensive than a traditional, counterparts.
Right.
If you want to, and also they're not available locally sometimes. I mean, if you want to access it in a country like us, it not be that easy to get that kind of sustainable material that can be reused. look at battery costs. I mean, we've been talking about it for a long time, and it continues to stay at a very high level, and it's still 60% of the vehicle cost today.
Yeah.
And if you want to go further to solid lithium, from the lithium iron towards that one, I find it's going to again increase the cost. So making cars like EVs affordable to the average customer is a challenge that we have. And if you want to go, I mean, we talked about EV a lot, but there's also a lot around hydrogen today, right? Hydrogen fuel cells.
Yeah.
It's a substantial R&D investment that have to come in, and infrastructure is not going to be easy. Building up H2 stations is going to be even more expensive than what we have expected of battery charging stations. So we know there are definitely solutions to make things better, which is more carbon neutral friendly, but it comes at a certain cost. And then comes on top supply chain constraints because of a lot of importing that we need to do. And then it also comes with recycling and battery usability. Logistics comes on top of it because that also adds to the emissions. So, and then comes to the manufacturing costs as well, because if you are talking about new technology, we need the retooling, new toolings. Right. We need to put in upfront investment for the energy efficient technologies, you know.
Yeah.
So it has entire value chain, adds up costs, and that is where it comes into the picture about how we're going to manage consumer price sensitive markets where everybody's looking for what is my ROI. So it's we are looking into it. Every part is being looked into it, and that's where what I gave an example of the X-in-1. And one of the reason for why we are moving toward X-in-1 is to bring down amount of material that we're going to use and kind of harness we need to use to connect them together in a vehicle. It can be minimized with if you can combine them together. Of course, it has its own risks with the high voltage. How do you manage high voltage current and its side effects of it to the other components? So going back to earlier question, does the legislation helps? Yes, I think to move such sustainability measures, we need initial push, which has to be in the form of certain incentives. We do have some in India, of course. FAME2 was there, but it's coming in a different form now.
Yeah.
There is this PLI, this production linked incentive that we have. There are some incentives are there, but it's not sufficient to move it faster to support green manufacturing. Because, for example, H2, we are talking about not a green hydrogen today. So you might have an H2 engine, but it may not be taking green hydrogen, maybe taking gray or other colors, right? But not the green, because it takes, again, a lot of money into it.
Yeah.
And infrastructure has to come in. So it is the entire ecosystem that has to play a role. And as companies, we are definitely looking at how do we minimize the material? How do we bring best recyclable materials? How do you bring more reusability? Even those components, can we get it back from the market and reuse some of those components, the sub-components for newer, products? So we're looking into many of this, but it's larger than that to look into the entire value chain.
Right. Ashish, I want to take your perspective on that, and I would like you to connect the dots here. I mean, this challenge of cost and the technology. So is there sort of is technology a binding element here, that it is enabling you to sort of also manage your cost increase, which is happening because of moving in the direction of these sustainable materials? Is there a global roadmap that CNH has already? And if you could give us a sense of how you're looking at it in going forward.
Yeah, I think it's pretty obvious. All of us know that our businesses are in the business of making money. So unless otherwise it makes commercial sense, you're not going to end up bringing something entirely new. Unless otherwise there is a regulatory push, right? So I agree with what Guru said. It has to be a combination. Certain regulatory framework will help accelerate the adoption of these materials. Also from the point of view of circularity, looking at the overall life cycle. But then internally within the company also fully embraces the spirit of working towards sustainability. But yes, in that spirit, you also want to make sure that you're making money, right? It's obvious. So I can take few examples, and those are very obvious, and they are there in all the industries. For example, when we are investing into autonomous tractors, big ones, we know that the performance is going to get better. Operator dependency comes down, the machines are going to operate more optimally.
Right.
And with all the intelligence through the sensors, the AI, all of that inside the machine, you'll be in a better position to predict when to do what in terms of maintenance. You might be in a better position to kind of extend the overall life of the operation of that machine. And if you work with your customer in a way, you are able to explain how they get the value through the life. See, again, let me just take a step aside here and put things in perspective. See, unlike automotive, we might be seen as an off-highway automotive company, but I look at it slightly differently. We make machines which are used by an industry to have a produce. So that industry can be agriculture or a construction industry. So these machines, tractor is a machine. You put multiple implements. Digital twins is very, 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 very obvious. In fact, right now we are looking at doing it for the whole life cycle. And this is where the circularity piece comes in. We are also thinking of bringing these at the requirements of the specification stage itself. Sustainability, a few years back, NPI processes, GPT processes, it was not part of the criteria, but today I have started to see this coming into the specification, and obviously designers will start to think through how to design the products, not just for the performance, but also from the standpoint of serving the goal of managing, maintaining, and delivering to sustainability and circularity.
Right, right. Thomas, if I may come to you, your thoughts on another element of technology, which is like, I mean, it could be clubbed within AI now. I mean, data analytics, how do you see that playing a role in sort of identifying into some inefficiencies, maybe in the process or maybe at any other level, to sort of then, curb that and move towards this broader goal of sustainability?
Yeah, absolutely. So I'm a first principles person. It means I try to break down challenges to its underlying fundamental problems and solve them. And I hold my teams to that. And when we engage with our customers, we see often that, products, like we said, is we're in the business to make money. But if we look into the fundamentals, the fundamental investments, I take a look at how India has approached artificial intelligence. And I see that, the opportunity to embrace AI, the opportunity with AI through fundamental investments, I don't see this at this moment that India tech industry has done this. We're skimping this, but we're trying to, serve on the monetization side. But the deep investments that are needed to really propel AI further are done in other places in the world. And, in January, we had a DeepSeek moment when we looked at, the ability to train apparently a model at significantly lower cost. There's some things that we still like to know closer. But I see us investing, for example, into chip technologies together with our IP partners, with our clients, where we are making AI chips that are orders of magnitude more efficient than today's technology. And now coming back to the data element of this, the shortcomings that we see is today, in order to create products that are, can be maintained and updated is the one aspect. But how do we create products that are capable of continuously improving themselves, products that are basically getting better every single day? These products need to be basically prepared from the very beginning to contribute to these improvement processes. And matter of fact is most products today are not. And it has to do with the product design, with the price points, with the markets. And I take the example of the passenger car segment. When Tesla launched Model 3, Tesla included a highly expensive supercomputer. That we know the price point of that supercomputer, and the customers did not pay for the supercomputer because they did not opt for the option in most cases that this computer potentially would support. And the cars were also equipped with a common sensing stack that allowed this OEM to extract continuously valuable information about the use of the product in an ever so complex real world. And this were in times where we as engineers still believe that we can create world formulas and describe the complexity of a world in algorithms. Apparently, we came to realize we cannot do this. And the challenges we have with assistance technology in the passenger car segment today, that these systems are very intrusive, these systems produce too many false positives, are outcomes of a traditional approach. In a new approach to design products, these products start learning from the experts who are operating them in the first place. And then we're trying to basically assimilate the use of the human expert as close as possible through, call it a loop technology. We call it cyclic AI here at Wipro. We can give it different names. But we're basically assimilating the human baseline. But it has to do with a product that is able to have the elements of embodied AI to a substantial part in the product itself. That's a pre-investment, which is often, not considered. So we are skimmed. We are only putting the technology into the product that the customer pays for on day number one, but we're not considering, to add the extra that we need. And this is why many, in the mobility space have today challenges in creating the necessary data so that their products can actually get better every day. And I believe we're seeing improvements in the passenger car segment. Some OEMs have, understood this now and basically added this to current lineups. Still, cars at a certain price point, especially when I look at the India market, where cars, need to be in in a different price segment. These technologies can already not be included again, which is a challenge. Okay. So I wish that we collectively could, use the advances in AI chips, the cost reduction, the power envelope that these chips are using, the performance, and equip products from the beginning with sufficient AI, I call it for simplification, horsepower. So we call it inferencing capacity, that these products are able to actually generate valuable data, not just data, because a lot of the data that we're collecting today is not really helping. We need to find the needle in the haystack right at the source. And we don't want to, pack on haystacks. We want to pack on needles. And it means it starts in the product. And even if I take an example of a machine, if the machine is operated by a human today, well, that's great because we can learn from that human. But in most cases, these machines cannot do this because they are not equipped with this. So it's a conundrum to be solved. So I see this as an opportunity. And looking at India, when Israel placed a probe on the moon, the world looked at India and was completely baffled, not only by the fact that it happened, but more or less by the cost that it happened. Yeah. So I've seen a lot of this ingenuity that is extremely valuable. And now that the world is reshaping global supply chain and manufacturing has to move wherever it is, for many various reasons, I think there is a huge opportunity to completely rethink manufacturing and start it all over in a different way. And manufacturing, we all talk about this term Industry 4.0 to the point that, I'm asking my teams, what is it really about? But the automation that was applied has a certain maturity. But I think now with the use of AI, we have a major opportunity to take this automation to the very next level. And that includes, the next generation of robotized technologies, whether this is, single axle robots, whether it's humanoid bots that can really change the way that manufacturing is moving forward. And we have an opportunity to start at this point in India and help our customers wherever these supply chains are changing to really reshape them and not just build another factory, based on the old principles, but to rethink this really and embrace that opportunity. I come from an automotive background myself, and when I see the opportunity with gigacasting, for example, creating huge structural elements in one pass, opposed to hundreds of single elements that need to be otherwise assembled together. It's a complex technology that requires, a long refinement and investments into this. But these are technologies that can really change the way manufacturing is happening. It might not be applicable to all industries. The heavy machine industry is obviously different than mass manufacturing other products. But I believe collectively we can learn, and this is not just speaking for my own company, but I see this opportunity with all our tech brains that we have in India, that we can really reshape the way manufacturing could advance. And as our customers need to act, are forced to act, this is a major growth opportunity for all of us.
Right. Gentlemen, just for the sake of time, I just want to get final comments from each one of you, and just extending what Thomas just mentioned here, what opportunities do you see going forward when you talk about designing and engineering in the automotive space from a circularity and a recyclability perspective? Srinivas, your thoughts on that? How do you see Indian engineers playing a role going forward, and companies like yours, where do we stand when we look at the global automotive trends towards sustainability? You're on mute, Srinivas.
Yeah. So it's our strong belief that, it's a very positive development, first of all. See, at the end of the day, any wave of infusion of technology, while initially there would be whether infrastructure or cost related barriers, they would shortly be overcome because it's a large industry. And once that happens, the adoption curve will automatically pull and everything will get streamlined. Now, looking at what it means from a circularity perspective, the one dimension that we have to work on as an industry, whether, at the end of the day, the industry is not about software or hardware or anything else. It is about mobility. And we have to look at how the end customer perceives the value of the change that is happening. And if we design for that change, for example, yes, you can use advanced materials, you can use battery technology, you can use hydrogen. For the customer, at the end of the day, it remains a convenient, safe transportation solution. And that is how, if you see, the industry has moved up and down from shared mobility to e-mobility, and different concepts have come in because probably not any one of them in isolation has met or ticked all the boxes which the customer is looking for.
Right.
The customer is looking for all of it together at one shot, but at the end of it, it is to be very safe, it has to be very reliable, and it has to be very economical.
Yeah.
And very often, if you see features, benefits, all of that start at the upper end of the pyramid. In auto industry, we have very well-defined segments, right? So the premium versus the mass. But most of these features very rapidly proliferate, and then they come to the mass segment where the price points are much more affordable. And that is what technology contributes. So I think we all have the opportunity to scale technology towards this sustainable mobility development, participate in it, and make it mainstream. And once we do that, the adoption curve will be far steeper, and everybody in this ecosystem is going to benefit from it. Most importantly is the end user.
Right. Ashish, your last thoughts on this?
Yeah, I'll keep it very simple and quick. See, from the standpoint of the design capabilities in India for our global organization, there are two areas where definitely we will be adding value in this goal of circularity sustainability. One is broader simulation-led engineering. And second, obviously, the capability of the country or the strength of the country in the software space. I think through those two areas, we will be making a difference for our global organization.
Right. Guru, last words to you. Ashish mentioned about software, and you are in one of that domains itself. So how do you see India playing a key role going forward when you talk about sustainability and circularity in the automotive ecosystem?
Yeah, I think the future of industry would be a lot more regionalized approach. You can't get global templates and implement it locally. That's not going to work. So which means that at industry level, at India, for example, we have to create which is very localized solutions. So it also means we need a lot more co-innovation and partnerships. So that today OEM supplier relationship has to become more stronger. And we work together with a stronger network. It can lead to shaping the legislation. It can lead to sharing the data to make things even better because technology is there. Like AI we talked about, unless there is data which can be used in the right way, AI cannot do much of it. So I feel joining hands, co-creating and co-innovating for the market, for the demands of the consumer, I would see it will be a huge benefit if you all join hands.
That's a great note to end this conversation on. Really appreciate, gentlemen, for your time. Thomas, Guru, Ashish, and Sreenivas. I hope it was an insightful conversation. I mean, we touched upon most of the bases here, simulation-led design. You're talking about sustainable raw materials, the policy push, and, incentivization and investments that need to be done by the industry, and a collaborative approach on top of it. So, I think all these are going to play a very key role going forward when you look at sustainability from a holistic perspective. Really appreciate all of your time. Thank you so much for joining in. Thank you so much.
Thanks, Mayank. It's a pleasure.
Thank you, Mayank.
Thank you, everyone.